Hi everyone, we are Team Blingtron. Welcome to our video presentation on CZ4046 Intelligent Agents Assignment. Our team consists of 5 members and our names are Zihao, Rachel, Christina, Guanwei, and me, Zihan. These are the areas of content for our presentation. Our agents are designed based on 2 different architecture styles. They are reactive architecture and hybrid architecture. The agents of reactive architecture react based on the changes in the environment. They retrieve percepts and respond accordingly to the events without maintaining any internal state. The agent act on a set of priorities based on their sensor readings as listed here. In our assignment, our agent's sensor readings include refueling, carrying a tile while locating a hole, found a tile and continue exploring, and also exploration itself. The intent of the agents are given a set of priorities. The priority level of the intent are as follows: refueling, followed by filling holes, followed by picking up tiles, and lastly exploring. The agents carry out these intents based on its sensor and memory information. The agents of hybrid architecture is a combination of reactive and deliberative components. The agents have reactive components responding to the changes in the environment without any complex reasoning and decision making. The deliberative component is responsible for planning and symbolic reasoning. The reactive component is in charge of deciding the action for the agent, whether or not the agent should pick or fail when standing on a tile or hole respectively. It also helps the agent to decide whether or not refueling should take action when standing on the refueling point. The deliberative component enables communication and collaboration with other agents and operates using intent. For every instruction step, it calculates the refueling threshold based on the distance from the agent back to the refueling point and takes into consideration the number of obstacles on the environment. From the information received from the other agent, the exploration path is then calculated. Tiles, holes, and obstacle location are being maintained in the agent's internal memory. This helps the agent to look back when there is no objects detected by the sensor's range. We design our agents based on the divide and conquer approach. The environment is divided by x-axis and y-axis based on the xy dimension of the environment. This ensures that the environment is being explored by the agents efficiently. Firstly, we determine which dimension is the shorter one by comparison. Next, the environment is being divided into 2 halves with respect to the shorter axis. If the environment is divided by the x-axis, Agent 1 will take the top half and Agent 2 will take the bottom half. If the environment is divided by the y-axis, Agent 1 will take the left half and Agent 2 will take the right half. For the exploration algorithm, the whole environment is being divided into 10 by 10 sections. The agents will filter through the list of sections so that further processing of the paths can be done. By dividing the whole environment into 10 by 10 sections, target waypoints are then created to set the agent's exploration path. The agent then calculates the distance from itself to each section, D1, and the distance from the section to the referring point, D2. The agent then checks if the sum of the distance D1 and D2 can be covered with 80% of its current fuel level. This is to ensure that the agent can efficiently proceed to the refueling station whenever the need to without worrying that obstacles may appear on the path towards refueling. By checking the current fuel level, it also ensures that the agent is able to move to the point without having the risk of running out of fuel midway. The agent will then add this section, highlighted in brown color, to the list of explorable points. With more explorable points, Many areas can be extended and explored to ensure full coverage of the entire environment. These sections are then further updated according to the divided environment so that each agent has an even number of exploration points. This allows the agent to explore the environment more efficiently and also to ensure that each agent do not step into one another's region to avoid interference. Agents share the location of their nearest tile, hole, and obstacle to one another. By doing so, the collision between agents can be avoided and the agents will not snatch tile with one another. Efficiency is also increased as if both agents went for the same tile all the time, only the score of one agent can be updated and the other one will remain with a score of 0. After that, agents will estimate the position of the ally based on the information obtained through communication. More information regarding the communication between agents will be explained later. The explorable area is again updated and the agent will then select a random point in the area. If the updated point has no viable paths, the agent will discard all the updates and explore the area as per normal. How do we achieve memory decay? The idea is by estimation. First, we estimate the lower boundary and the upper boundary of the decay timer. This is done by taking the average of the two boundaries. The agent will remove the object from its memory when the time that the object is present in the memory is greater than the decay timer. We initialize the lower boundary and upper boundary to a value of 0 and 1000 respectively. How the values of the boundaries are being updated will be in the next slide. There are three different types of data structures present in the memory decay and each of them serves a different purpose. Past per step stores the agent's previous step into the memory. Vision stores the agent's current step with regards to the sensor range. Decay per step is the list of objects in the environment that the agent sensed prior to their creation. The decay timer estimation algorithm was created to estimate the decay timer for the agent to suit each configuration. First, the agent loops through the intersection of past percept and vision before updating the decay percept and lower and upper boundary. Here, we illustrate how the intersection of the past percept and vision is being obtained. The agent is represented with a blue triangle. The orange area shows the agent's vision, which is obtained by the sensor readings. The current step now is 0. At the next step, the agent will move to the right. At step 1, the agent has already moved to the right. The red area marks the past percept, which is the area that the agent has been to previously. This area is stored into the agent's memory. The different layers you see now shows the different point of views of the agent at step 0 and at step 1 to illustrate how the red and orange areas are being marked out. After that, we mark the intersection of the two areas in green. This intersection will be used later to calculate our boundary values for the decay timer. If the item is not in past percept but is in vision, the object will be added to the decay percept. This is to illustrate that the agent sensed a new item being created. The agent will then check if the object is in both past percept and vision. The lower boundary will be calculated. The calculation is done by taking the difference of the current system time and the time when the agent first saw the item. Next, the agent checks if the object is in past percept but not in vision. After that, if the object is in decay percept, the upper boundary will be calculated by taking the difference of the current system time and the item creation time. The object is then removed from the decay percept. Agents pass 3 units of information to each other. These units are nearest tile position, nearest hole position, and the nearest obstacle position with respect to the project specifications. These information are retrieved from the agent's memory percept. The receiving agent will then process this information to determine the sender's position. This is to ensure that the agents do not overlap each other's exploration paths. We will now proceed to the demonstration of the agents. Reactive agents will be showed first, followed by the hybrid agents in the 3 configurations. The total score of the agents are being summed together and the average is being obtained after 10 runs. This is to ensure that the agents are robust. We can see that the hybrid agent score is much higher than the reactive agents due to their nature. That is the end of our presentation. Thank you for watching.